1905 was a very important year for the life of Einstein. It's called his miracle year. He came out with 4 really important papers, one of which was the paper explaining special relativity. A few months later, he put out a second paper, which was a little attachment to the theory of special relativity, the equivalence of mass and energy. That is E equals mc squared, an equation you may have heard of. Now, this came from some fancy maths involving involving time dilation length contraction, which changes amounts of kinetic energy, and then thinking about the conservation of energy allowed him to come up with E equals mc squared, where E is the amount of energy in joules, m is mass in kilograms, and c squared, or c stands for the speed of light. So this is an equivalence. If in some circumstances mass is converting into energy, or energy is converting into mass, they will obey this equation. So small amounts of mass turn into large amounts of energy, right? Because it's mass times the speed of light squared, huge numbers, giving you how much energy you've got. Okay, so this dot point wants us to calculate energy released by processes in which mass is converted to energy. For example, in the combustion of conventional fuel, you might have an equation like hydrogen plus oxygen, except there are 2's, is converted into H2O. It's the combustion of hydrogen, except in order to balance this, we need to have 2's here. Okay, in this process, you actually have higher mass on the left than on the right, and so some energy is added to this as well. If you calculate the exact amounts of mass in every molecule, and you minus this side from this side, you get an amount of mass left over, which is equivalent to energy. Same principle applies in all the situations. Let's go through a couple. So, production of energy by the sun. The sun loses billions of kilograms of mass every second. It loses 6 times 10 to the 9 kilograms of mass per second. It is a lot of mass lost by the sun, and this is not mass lost as the solar wind, the particles coming off the sun. That actually is a very small amount of mass lost compared to this number. This number per second is huge. This one is lost as hydrogen fuses into helium. When that happens, when you add together the stuff you start with, in this case hydrogen atoms, and you add together the mass of the stuff you end with, in that case helium, plus some other bits, they are not the same. You started off with higher mass, you ended up with less mass. How much less mass? This much. So if we were to plug it into the equation, this is the mass, so we just need to times it by c squared. So the amount of energy we're going to end up with is going to be 6 times 10 to the 9. That's our mass. mc squared times c squared, which is 3 times 10 to the 8 squared. And that gives us 5.4 times 10 to the 26 joules. What a huge number. This is all the energy coming out of the sun. This is why the sun is hot. This is why the sun releases light. This is why the earth is allowed to have life and liquid water and all the good things. Right? It's because the sun's producing heaps and heaps and heaps of energy. Okay, last example. Particle-antiparticle interactions. Example, positron-electron annihilation. So a positron is the antiparticle of an electron. When you have matter and antimatter, when it collides, they are completely converted from mass into energy. All their mass is converted. This is the plot line of that Dan Brown book. Anyway, positron and electron. So, positron colliding with electron. I think the symbols are usually still E, but they put like a E plus and E minus. Yep, when they collide, all their mass is converted to energy. How much mass? Well, we just need to have a look at our formula sheet. Mass of an electron, 9.109 times 10 to the negative 31. Very, very small. That's for our electron. 9.109 times 10 to the negative 34 kilograms. And conveniently, this amount of mass is the exact same for the positron, which is also 9.109 times 10 to the negative 34 kilograms. So really we just have to double this mass to work out how much mass is there, times it by c squared, and we get very small masses, so we get a very tiny number. We end up with E equals 1.6 times 10 to the negative 13 joules. Okay, a very tiny number for very tiny masses. However, if you had a lot of antimatter, say a kilogram of antimatter annihilating with another kilogram of regular matter, 2 kilograms worth, that's 2 kilograms, the number 2, times 3 times 10 to the 8 squared. You have billions and billions of joules of energy released at one time. It would not be fun. Okay, that's it. Module done.